All right, section 3.3, there is a very key word in our essential question. It says, for which of the theorems involving parallel lines, we talked about 4 theorems yesterday. 3 of them were congruent theorems. 1 of them was 180, added up to 180. Remember, there was only the 2 choices. Either they're equal or they add up to 180 when you've got parallel lines. But it says, which of those theorems for parallel lines and transversals is the converse true? Converse. So we want to look at that word converse. I know we went through chapter 2 really fast, so you might not remember converse. We used a couple of letters in chapter 2. Do you remember these letters that we talked about? P to Q. Do you remember what that meant? P to Q. It meant if P happens, then Q happens. If P, then Q. So if an angle is a right angle, then its measures 90 degrees. So if this happens, then this happens. That's the if-then statement. Well, the converse is when we switch it around and we go Q to P. So we would go if Q happens, then P happens. Now that might end up being a true statement. It might be not a true statement now. It might be true if it's P to Q and then false if it's Q to P. But in this case, they're asking us which ones, when we switch it around, are true. So yesterday we had some theorems, 4 of them. The first one of those theorems is right there, corresponding angles. And you can see it's an if-then statement. It's got your if, it's got your then. If parallel lines are cut by a transversal, then corresponding angles are congruent. Basically what it says. So if I switch that around, I would be putting if corresponding angles are congruent. I'll abbreviate angle symbol. If corresponding angles are congruent, use the congruent symbol, then the lines are parallel. Okay, so if you've got 2 corresponding angles that are equal, like this picture over here, if 1 and 5 are the same, the only way that happens is that means that these lines had to have been parallel. These angles cannot equal each other unless those lines are parallel. So if the angles are equal, yes, the lines are then parallel. Okay, that has to happen. That is a true statement. The second one, it says if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. The converse, and we can shorten it up a little bit, if, and I'll use my abbreviations, alt for alternate, int for interior, and then the angle symbol. If alternate interior angles are congruent, then the lines are parallel. And use the parallel symbol. Again, another true statement. If 3 and 5 are the same, if 3 equals 5, the only way that happens is that you had parallel lines. It cannot happen unless the lines are parallel. So yeah, if you can show me those 2 angles are equal, then I'll be able to say, yeah, those are parallel lines for sure. And it works the same for alternate exterior as well. So if alternate exterior angles are congruent, then the lines are parallel. So that's also a true statement. So those are our 3 parallel congruent ones. So if this one is congruent to that 7, then yes, those lines must have been parallel for that to happen. Same thing with 4 and 6. So you can switch those 3 around and they stay as true statements. And they would actually be proving that the lines then are parallel. Because you're giving me the angles congruent, now you're proving that the lines are parallel. The fourth one up here is the one that's supplementary. So consecutive interior angles. If parallel lines are cut by a transversal, the pairs of consecutive interior angles are supplementary. So we're going to start with if consecutive interior, INT, angles, we'll do the angle symbol, are supplementary. I'll just put sup. Then the lines are parallel. So if the consecutive interior angles are supplementary, the lines must have been parallel. On the picture, what that means is if these two angles add up to 180, that means the two lines then for sure had to have been parallel. That means they definitely would have the arrowheads on it because they had to have been parallel. For them to add up to 180, those lines must have been parallel lines. So that would be your four theorems. And then your communicate your answer saying which ones of them, which ones of those theorems are true, and they all are true, all of them. All four of them are true. We're not going to do three, so we'll move on. Some vocab terms, there looks like a lot. We're just going to go ahead and briefly remind ourselves because we've seen all these before. So I'm not going to re-go over all their long definitions. I'm just going to briefly remind you that converse means to switch P and Q. So instead of if P then Q, it's going to be if Q then P. So converse, you could put down here Q to P statements is what it actually is. Parallel lines, just remind yourself they have the same slopes because we're going to be talking about parallel slopes next section. So parallel lines have the same slopes, same direction. Transversals, they intersect two or more lines. So transversals, they simply intersect two or more lines. The congruent is kind of, I don't know why they put corresponding then congruent. We know what congruent means. It just means equal measures. So if like two angles have the same degrees, they're equal measures. That means they're congruent angles. Or if two segments have the same measure, they're equal or congruent. These other four that are surrounding it, these four, those are the angle pairs with parallel lines. That we talked about yesterday, and we said that corresponding ones were congruent, that alternate interior ones were congruent, that alternate exterior ones were congruent, and that consecutive interior ones were supplementary. And next to that, I'll put 180 degrees. So that's what we said yesterday about those four pairs of angles when you have parallel lines. If the lines are parallel, then you've got three of them that are congruent pairs and one of them that's going to be a pair that adds up to 180. The next theorems are just what we already wrote down. So we already wrote down if corresponding angles are congruent, then the lines are parallel. We wrote it on the first page. So we don't need to rewrite the theorems, but they are there for you. You could see this picture. If you see this picture right there on a page and they're asking you, can you prove they're parallel? Yeah, they're parallel because corresponding angles are congruent. You would then be allowed to draw the arrows in there because they would have to be parallel. Those lines would have to be parallel. You can put those arrows now because they are corresponding angles are congruent. Same thing up here. If you see alternate interior angles, you would then be allowed to draw in the arrows because they have to be parallel. If 4 and 5 are equal, the only way they could equal is if the lines are parallel. So those would have to be parallel lines. Same thing with 1 and 8. If you see 1 and 8 are equal, then J and K have to be parallel to each other. There's no other way that 1 and 8 can be equal unless they're parallel lines. And if you see that 3 and 5 add up to 180, then you could put the arrows in there because they have to be parallel. Have to be. So that would be the 4 theorems. There is one last theorem, though, in here that's we haven't seen yet, and it's that transitive property again. Remember, transitive was if two things, like two angles or two segments, if they equal the same segment or angle, then they have to equal each other. Well, it works for parallel also, because look what happens. Look at this first statement right here, P parallel to Q. So if I know that P is parallel to Q, I'm going to make an arrow on P and an arrow on Q because they're parallel. And what does the second little statement say? Q is parallel to R. So Q is a common line, and it's got one arrow on it. So R is also parallel. It's got one arrow on it. So P is parallel to Q, and R is also parallel to Q. So what does that tell me about P to R? That they have to be parallel also. They're both going to have one arrow. You see, they both have an arrowhead on it. So they are also parallel. So if they're both parallel to Q, then they're going to be parallel to each other. That's what it says. And that takes us to the extra practice. Like I said, these go pretty quick. You remember the two choices when we solve for x? Your two choices are equal. They're either going to be congruent or they're going to add up to 180. Those are the only two choices for solving for x with parallel lines. It's one or the other. So what do you think about number one? Equal or do they add up to 180? When I'm looking at this, I see corresponding angles. Corresponding angles are always congruent. So I would make 95 equal to 8x plus 55. And I would subtract 55 on both sides. So you get 40 equals 8x. Divide by 8, and you get x is 5. What that means is if you put a 5 in for x, then you have to have parallel lines. If you put another number in for x, then they're not parallel. But if you tell me that you're plugging in a 5 in there, you could then put the arrowheads on there because they would have to be parallel if x is 5. And we made them equal because these were corresponding angles. Corresponding angles are congruent. The lines must be parallel if that is the case. If corresponding angles are congruent, the lines have to be parallel. Have to be. If you look at 2, what do you think? Congruent or 180? This one looks really big angle, really big obtuse angle. This one looks like a really big obtuse angle. What do you think? Equal or add up to 180? If they're both more than 90, they're not going to add up to 180, are they? They're going to be way over 180. So that means these have to be equal. These are alternate exterior. Alternate exterior angles are congruent. So you're going to take the 200 minus 2x, and you're going to set that equal to 130. So I would subtract my 200 on both sides. So you still have a negative 2x. That negative doesn't go anywhere. And you get negative 70. And when you divide by negative 2 on both sides, you're going to get a positive 35 for your x value. So if x is 35, then you would be allowed to put the parallel line arrows on M and N because they have to be parallel if x is 35. If x happens to be a different number, then they're not parallel lines. They would be different angles. So you're going to have a couple of those to do tonight to find out what value of x makes them parallel. And then you'll have a couple where you just got to say yes or no. Yes, there's enough information. No, there's not. So let's look at number 3. Is there enough information to prove that M is parallel to N? Can you say with 100% certainty that M and N are going the same exact direction? And the answer to number 3 is yes, those are corresponding angles. If you find corresponding angles congruent, if you find that corresponding angles are congruent, then your lines have to be parallel. So you could then put parallel line arrows on there. And that would be a definite yes. Number 4, though, number 4 is not enough information. Because vertical angles are not one of our theorems. There is no angle down here in this section at the bottom. You need an angle down in N somewhere too to show that N and M have to be parallel. And in that picture, you don't have any angles down here in N. You've only got 2 angles up by M. So we don't have enough information to say that M and N are parallel. They could be, but they don't have to be. It's not like proven. Same thing with 5. Again, you've got vertical angles. That's not enough info. You need more. You need something that tells me there's an angle down here in N that's also congruent so that you could say M and N are parallel. And that's not there. So definitely not parallel lines there. You don't have enough information. Now, again, they could be parallel. M might be parallel to N. I'm not saying they're not. I'm saying you don't have enough information to prove that they are. But 6, you do have enough information. You've got alternate exterior angles. Alternate exterior angles are congruent. So you can say that N and M are parallel because you've got an angle on M with R and you've got an angle on N with R, and they're alternate exterior. Could I put an arrowhead on S also that it's also parallel? No, I can't put one there. It might be parallel, but they didn't give me any angles in here, so I don't know. I would have to have an angle in there that's congruent to one of the other angles. That would allow me to say S is also parallel, and right now that doesn't. All right, so that was 3-3. Let's quickly go through 3-4. It's also pretty fast. Let's go to, we're going to skip over this first one, except the essential question. We want the essential question. We're going to be talking about perpendicular lines in this section right here. So it says, what conjectures can you make about perpendicular lines? We haven't talked about conjectures yet. Conjecture. A conjecture is an observation, or it's basically it's an unproven statement based on observations. So let's say that I asked all 8 of you in this side over here what color of your eyes. And let's say all 8 of them had brown eyes. So I could say, well, all my students have brown eyes. That could be a conjecture. Is it true or is it not true? It might not be true. It might be true. But it's a conjecture. It's my guess based on what I saw. I saw 8 people with brown eyes, so I'm saying that everybody has brown eyes. So it's like a guess. It's like your guess based on what you've seen. Okay, so you look at observations and you make a guess. So here's what I would put for conjecture. A guess based on observations. So you could use the whole technical definition of an unproven statement based on observations, but it's kind of like your guess as to what's going to happen. It's like a hypothesis in science. You're going to try to prove it. You're trying to prove that it's true. So what kind of things do we know to be true? What kind of things do we know to be true about perpendicular lines for our communicate here? What kind of things? Well, let's look back up at this picture right here. How do I know that those lines are perpendicular? I know it because we did some constructions already, and I went over them yesterday with you. Two of them. I went over one, a really important one, which was this one right here, but they turned it sideways. So if you look at it right now, it looks like it's sideways compared to what I did it yesterday. If you turn your book sideways, it might look the same because I called it the fish yesterday. They just did the little arcs on top and bottom where they intersected, but they could have done the whole arc here and the whole arc here and made a fish. Okay, so they did the little one, but that makes parallel line or perpendicular lines, and it makes a bisector also. So it makes right angle or makes equal pieces. So those are perpendicular lines, and it's a bisector. But that's not what it's asking right now. The communicate is asking us what can we say to be true about perpendicular lines? What kind of things do we know to be true? What would be our guess about perpendicular lines? Well, one guess I would say is that they make right angles. So make right angles. And you could also kind of put in there that they make 4 right angles, not just one. So on this picture right here, you could actually put a right angle box in any of these angles. Those are all going to be right angles. So they make 4 right angles. And I do want to say one thing about perpendicular lines with their slopes, because the next tomorrow or Thursday, we are going to be looking at slopes of parallel and perpendicular. So slopes of perpendicular lines. Do you remember what their slopes are? Two things that we said about the slopes of perpendicular lines. They're opposites and reciprocals. Opposites and reciprocals. You have to change the sign, you have to flip it over. For that to be a perpendicular slope, it's got to be the opposite sign and it's got to be the reciprocal. All right, there's a couple of vocab, just two. Okay, perpendicular, bisector. Okay, it intersects. I'm going to save the top one because it's a very important one, and I want to go over that one. So the bottom one we've already seen before. The bottom one is what you do when you make a fish. So it intersects a segment at its midpoint. Because midpoint would be the bisector. Intersects a segment. It's got to be a segment because it's got to cut it in half. So it intersects a segment at its midpoint and makes right angles because it's perpendicular too. So that's what a perpendicular bisector. It intersects a segment at its midpoint, so it makes 2 equal pieces, bisector, and it's going to make right angles because it's perpendicular. Now, distance from a point to a line. Okay, that one basically it's if they make a dot on a graph and they draw a line on a graph somewhere. They want to say how far is that point from that line? So if I was to draw you a little picture, it'd be like you having a line and you having a dot. And how far is that dot from that line? Well, would I measure it to the end of the line? Would I measure it to this end of the line? Would I measure it to the middle? Or would I measure it at a right angle? Hint, hint, that's the one you want to look at. Okay, so circle that because when you want to measure a point to a line, you got to measure it from a right angle. So it's the distance to the line at a right angle. That's going to be on your homework. There's 2 questions on it. It's the distance to the line at a right angle. So it has to be a right angle. You can't find the distance to a side, to an end. It's got to be the distance to the line from a right angle. There's just a couple of quick little theorems here that you might want to look at. Linear pair perpendicular. Basically, if 2 angles are a linear pair, like 1 and 2 make that straight line, right? And if they're congruent angles, the only way you could have a linear pair and them being congruent is if they're both 90. So that means the lines would have to be perpendicular because they make 90-degree angles. So if linear pairs are equal, then they're both 90, then the lines are perpendicular. If you've got 2 lines that are parallel, okay, you see the parallel arrows there? And J is perpendicular to H, and H and K are parallel to each other, then that means that J has to be also perpendicular to K, because H and K are going the same direction. If it's perpendicular to one, it's going to be perpendicular to the other if they're going the same direction. So if you see parallel lines and one's perpendicular to J, then the other one is also perpendicular. And then there's one last theorem up here. It's kind of the converse of that. But if you've got M is perpendicular to P and N is also perpendicular to P, if they're both perpendicular to P, that means they have to be going the same direction. That means they have to be parallel. You can put the arrows up here because they would have had to have been parallel for them to both be perpendicular. If they're making right angles to P, both of them are making right angles. That means they're going the same direction. So that was your couple theorems. Let's look at the extra practice. So like I said, there's going to be a couple on your homework that you're going to do. We're going to do numbers 1 and 3, but we will look at 2 and 4 just for a second. If you're looking at that one, do I need to measure the distance from A to C to get the distance from A to BC? Or how about A to D? Or how about A to B? Which one do you think will give me the distance from point A to the line? It has to be the one where the right angle is, right? So it has to be letter D, AD. That's got the right angle. So, in other words, how do I find that distance? Well, on a graph, we said you could use Pythagorean theorem. 2 and 2, and we drew in the little right triangle. And we can do 2 squared plus 2 squared equals C squared. You get 4 plus 4, and then you get 8, and you square root both sides. You get C. C is approximately 2.83 units when you round it off. 2.83 units is the distance from point A to the line. If they were to ask you what's the distance from point A to that line, you would have to draw in the perpendicular line and measure that perpendicular line, or solve for it and see what you get. Now, if they don't give you a graph and they just give you an equation and a point, and they say, how far is this point from this equation? You're going to have to draw it. You're going to have to draw it so that you can make another opposite reciprocal slope and find out the perpendicular line. There are going to be some that are going to be a little trickier like that, so just wanted to see it. Which line do you think I'd have to measure on number 2? AC, AD, or AB? Which one would give me the distance from point A to the line? Has to be the one with the right angle. It's got to be AD. That's the one you'd measure. What about number 3? Which one do we measure here? AB, AD, or AC? See the right angle there? It's got to be AC. So you would make your little right triangle. You got 4 on the bottom. You got 2 on the side. So you would do 4 squared plus 2 squared equals C squared. You got 16 plus 4. So that's 20 equals C squared, and then you would square root 20. So the square root of 20 is 4.47. And that's units. So that's how you find the distance from a point to a line. You find its perpendicular distance. Which line would we measure in number 4 to see how far A is from the line? You would measure AC is right. AC has the right angle. You're looking for the right angle. All right, let's skip down to 5. Which lines, if any, must be parallel? Must be parallel. Do you notice that they gave us a right angle for P to S, but nothing in Q to S? So this one, you would have to put not enough information. You need an angle in Q somewhere also. So not enough info. Number 6. You've got P is perpendicular to R, you've got Q is perpendicular to R. So yes, you could say that P is perpendicular to Q, or parallel to Q. P is parallel to Q. They're both perpendicular to R. If they're both perpendicular to the same line, then they have to be parallel to each other. So you could actually put the little arrowheads on P and Q. They have to be parallel to each other. Number 7, alphabetical order. J and K are both perpendicular to M. So yes, J is parallel to K, both perpendicular to M. So you could put arrows on J and on K. They have to be parallel. You could also say that M is parallel to N. Okay, they're both perpendicular to K. Both perpendicular to K. So you could put the double arrows on M and N. 2 arrows to 2 arrows. Those would have to also be parallel. 8, 1, and 2 are equal. That means they have to be 90 degrees. So you could say that M is definitely parallel to N. They're both perpendicular to S. Both perpendicular to S. So M has an arrowhead on it, and N will have an arrowhead on it. You could also say S is parallel to T because they're both perpendicular to N. Both perpendicular to N. So yeah, you can put the double arrows on S and T. All right, so that is 3-4.